So we're going to start with the pointers. So in this, value of address of another variable. Pointer is nothing, is just store address of another variable. Like any variable or constant, you must declare a pointer before you can work with it. It means, so generally what we do is we write int a equals to 10. This means is a is a normal variable that is of integer type and we initialize value with 10. So this is what it means. It means a has given some memory in the RAM that it is going to store value 10. So how to declare a pointer and how to write that initialization, how to initialize that value. So as I already told, that pointer variable stores the address of normal variable. So pointer here, ptr is a pointer variable which store address of a. How to write that? Here we write int star ptr equals to ampersand of a. Ampersand of a means address of a. It means ptr is going to store address of a. Here integer defines not the data type of pointer, here integer defines the data type of a. So ptr is always going to be integer only because it is an address, and whatever the address we write in an memory, that is stored in integer only. That is going to be some value, integer value only. So star ptr is the declaration of the pointer and ampersand a means address of a, that I already told. Now if I print out cout ptr, it is going to print some address value only. And if I write cout star ptr, that is going to give some value present at that address. What I mean by these things is I am going to go to the VS Code and I'll explain lot about pointers. Like what is dereference operator? We say this as the dereference operator also. Suppose we define that a equals to 10. So it is going to have some address, and after that 125, 126, 127, these are the addresses will be there. So when I define a equals to 10, it means it address 1024 is going to be stored in ptr. It means when I cout ptr, that is going to print 1024 that time. It is not going to print 10. So that is a value of a, not ptr. ptr is what? It's a pointer variable, and pointer variable always stores address of normal variable. When I dereference it, it means when I use this star, we call this star operator as a dereference operator. So when you dereference ptr, it means we're going to jump here in the address and say what is there in this address. What is there in this address is 10. What is there in this address is value 10. So when I dereference this ptr, then that time it is going to give the value of that address. So that is what dereference operator means. Now move to the next part of that. So this is int a is declaration of normal variable. So when we write int a, it means it is going to give some space in the memory, that a is going to take 4 bytes of memory, and each byte take, 1 byte is equals to 8 bits of data, that we already know. This is memory of address is given in the memory when we write this int a. A is the integer type, so it has 4 bytes of memory, and address of a will be, let's suppose 1024. We are just considering to be 1024. It can be anything according to the machine, whatever we are using. So we consider the first address of the memory block of the variable. So here a value is going to be stored and this is going to be remain empty. So when I write a equals to 7, then 7 is going to be stored here, right? So that's how it is defined. Now using pointers in C++, there are few important operations we'll do in a pointers in very frequent. We define a pointer variable, assign the address of a variable to a pointer, and finally access the address available in that pointer variable. So all things we're going to do in the VS Code. So done by using unary operator. So this is As I already told, this is what dereference operator. This is going to give the value whatever present there in that place. Now we will jump to the VS Code and we'll do tons of problems there using pointers. How to define a pointer, how to declare it, and how to access it, and how to find the address, and how it is related to arrays, and everything. We'll be talking tons about pointers. We want to take tons of examples there so that it is very clear. And what is the difference between reference variable, what is the difference between normal variable, what is the difference between a pointer variable, everything I'm going to talk about. That ampersand operator, what is address of, and what are the things, how to define and how to initialize, everything we're going to talk about. Now let's jump to that VS Code and let's see all the examples and learn everything. Now let's understand reference variable, normal variable and pointer variable in very details. So we're going to deep dive into it. So before that, let me create a program that and name it as 10 pointer.cpp. Now we're going to deep dive into the pointer variable, reference variable, normal variable, how to access, what is the address, and everything, each and everything we're going to deep dive into it. So before that, I'll just clear the terminal, clear, I'll hit enter. All right, now we'll write the header file that we do for the C++ program, include iostream, and I'll write using namespace std. All right, this is done. Now I'm going to write main function. For that, int main, and I'll give round bracket and then curly braces. All right, now we have to understand the normal variable. So let's go forward with the normal variable first. So suppose I want to declare and initialize some normal variable. So if I write int x equals to 2, it means what? It is initialization of variable x. It means x is given some space in the memory that it is going to store some value. Here x is of integer type, so it is going to store integer. So I have written x equals to 2. All right, now I'll create reference variable for this x. So what does reference variable means? Reference variable means it's just another name of the x. It means, suppose my name is Amit, so my nickname will going to be there. My nickname is Krishnakant, suppose. So what it means is Krishnakant and Amit both are the same entity. If I say Krishnakant has 2 eyes and 2 hands, it means what? Amit also has 2 eyes and 2 hands. If I say today Krishnakant went to McDonald's, it means Amit also went to McDonald's. So what reference variable means is, here Krishnakant is reference variable to Amit. It means reference variable is just nothing, it's just another name, just allies of that variable. So that is what reference variable is. When we declare reference variable, it means we are giving just another name. It means in the memory, it will not have separate space in the memory. It will have same memory allocation whatever the original value have. Original variable has memory. So that is what reference variable. Now let's write and we'll see that thing in the code also. So let's create a reference variable for x. For creating reference variable, we write int ampersand of y and we write x. It means y is reference variable. Y is reference variable of x. Here y is just another name of x. Y is just another reference of x. Y is just another alias of x. You can say this way. It means whatever the value x has, y also has the same value. So if I print cout y, that is going to print only 2 because y is just another name of x. That is what reference variable is. I'm stressing out so that you don't get confused whenever you hear the term reference variable, pointer variable, normal variable. So here I am going to cover these three variables in very details and we're going to deep dive into it. Now let's suppose we want to create pointer variable for x. For creating pointer variable of x, what I'm going to do is, suppose let's name the pointer variable as z, and that is going to be ampersand of x. It means, what it means is, z is the pointer variable. Z is the pointer variable of x. It means what? Z is storing address of x. Z is storing address of x. This is what? Normal variable. X is normal variable, y is reference variable, and z is the pointer variable. It means z is storing the address of x. This ampersand x is read as address of x. It means z is storing the address of x. That is what pointer variable work is. Pointer variable work is to store the address of some variable. Here we are storing address of x. So we're going to print out and we're going to see how address looks like. Alright. Now, if I write something here, suppose I write y equals to 67. It means we updated the value of y to 67. It means we update the value of x also, because y and x are the same thing. Y and x are the same thing, right? So we updated the value of x also, because y and x are same name. Both are nicknames of each other, right? So if I updated y here, that is going to update x also, alright, because that is what reference variable is. Now if I do cout, let's see and write cout statement. Suppose I want to print value of x and I write x here. Now if and I'll give endl statement here also, endl, alright. So we want to print the value of x. Now if I save the code, what will be the value of x? Will the value of x will be 2? No. Value of x will not be 2 because it changed to, let's see what is coming. Let's run the code and see what it is coming. Its value is showing as 67. You see, we given x value is equal to 2, but in line number 11, we updated the value y equals to 67. Why? Because y is just, we created reference variable of x. It means y is just another name of x. We are changing in y, it means we are changing in x also. So that's why y value is also 67, x value is also 67. Now if I print here y value also, that is going to come as 67 only. So what if I write value of y, what it is going to come? It is going to come as 67 only, because y and x are both the same things. I'll hit Ctrl S, I'll run the code here. So after running the code, value of x is 67, value of y is 67. Here I'll give some space so it will look better. Now if I save the code, Ctrl S, I'll hit and I'll run the code. Value of x is 67, value of y is 67. Now we want to see the address of x. Suppose we want to see the address of x. Address of x is stored in where? Address of x is stored in z, right? That is pointer variable. But without writing that pointer variable, we can see the address of x still. How to see address of x? Cout, and if I write address of x, and that is going to printed by whom? This ampersand of x. Both are the same thing. So this endl, if I write here directly z or address of x, this is how it is read. This line, this is read as address of x. Ampersand x means read as address of x. So if I print this, this will print whatever the value stored in address of x. If I run the code, then it is going to print address of x. Some integer value, that is hexadecimal value, is something is coming out. So this is what? Integral value, that is address of x. It is printing. Now if I want to print address of y, what do you guys think that address of y will come out? What I said, address of y. If I want to print address of y, what do you think it is going to print? If I write address of y and I write endl statement here and I save the code, Control S, and I run the code. After running the code, if you see, both address are same. What I said, they don't, initially I said that x and y are the same thing, only the name is different. They are the nicknames of each other. That's why their addresses of that memory allocation is also same. Their value is also same. It means they are not allocated in the different memory allocations, right? So this is very important. All right, I'll clear the terminal now. All right, so this much we saw. Now we want to find the address of x. So we know that pointer value variable store the address of x, isn't it? So I'll write cout, and if I write address of x is, that is stored in where? That is stored in pointer variable. So if what is the pointer variable? Z is the pointer variable. All right, if I write this z, it is going to print the address of x, that is similar to whatever it is printing. If I run this code, so you see z, address of x, is also printing the last statement. This is also printing, z is also printing the same address, because z is storing the address of x, right? And this is how we declare int star z equals to ampersand of x. Okay, how to recognize that this is a reference variable or this is a pointer variable? When assignment operator is there and left side of assignment operator ampersand is written, that time that is a reference variable. When right side of assignment operator ampersand sign is there, that time it is a pointer variable. We are defining pointer variable, that is the recognition. All right, so address of x is stored in z. Now what I said, we can write, all right, one thing one can do is, address of y is, if I write, that is also stored in the z only, isn't it? Because that's, y is nothing, just it's a reference variable of x. So if I write endl and if I control save is the code and I'll run the code again, and you see all the values are same, because whether it is address is stored in y, that is stored in z only, or ampersand y right, ampersand x right, both are all are the same things. All right, this is done. Now we're going to see that if I dereference it, what is the value it is giving. Now if I want to find the value at that address, right? So if I write value stored at pointer variable of x. So for finding value, what we do is we dereference it. For dereference, we use the star operator. And if I write z, if I simply write z, that is going to print address, because that's a pointer variable. When I dereference the pointer variable, that is go into the address and try to find the value. So that is what is work of the star is. So if I write this and I write endl and I'll save the code, so it will going to give whatever the value present at z. So what is value present at z at that address? That address value is 2, not 2, that's 67, because we updated it, isn't it? At the last we updated it. Now if I run this code and it's saying what? It is printing the stored value stored at pointer variable of x is 67. So this is what it is printing. All right, one more thing. If this is address of x, this ampersand x is similar to z, isn't it? Now if I dereference this also, that should also give the same value, isn't it? Now if I write cout, and here if I write value at address of x, that is ampersand of x is, so for that what I have to write, I have to write dereference and ampersand of x. This ampersand x is acting as what? Z, that is address of x, that is stored in the pointer variable, right? If I write endl, that is going to print 67 only, because it is just updated. We just updated from 2 to 67. If I save the code and I run this code, and it will show that value is at address of x is 67, right? I'll clear this terminal now. All right, now we'll do some more things. Suppose I update the value here as x equals to 78. Now if I run this code, control S, if I run this code, so now everything should get updated to 78. You see, value of x is 78, y is 78, whatever the address are there, that is going to remain same, and all values are 78. Same thing we can do with the address of y also. If I write cout, and if I write value at address of, here I have to write of value at address of y, that is address of y, this is how we read, is what I have to write? I have to dereference it, star operator, I have to dereference it, that is going to write star operator, and inside the bracket we're going to write address of y, that is also going to give the same value, and L. And I'll save the code, control S, I'll right click, run the code, and if you see, the value is coming at 78 only, because in line number 12 we just updated those values. So these are the all about pointer variable, reference variable, and normal variable. This should clear every point, each and every point. So I'll whenever I'll teach you dynamic memory allocation, that time I'll be showing you this pointer, I'll be teaching about this pointer, and I'll be teaching about arrow operator and everything, and we'll pass the pointer in a function also. Now we're going to deep dive into it. Now we're going to see the next example, that is going to be how to, like, that is call by pointer. We left that part whenever in the function calling we saw there pass by value and pass by reference. Now we're going to see by call by pointer or pass by pointer. Now we're going to see that. This should clear all the doubts regarding reference variable, pointer variable, and normal variable. Remember, normal variable going to store some value in it. Reference variable also going to some value in it, but that is just nickname of that another variable, right? So it does not allocate another memory. It has same memory location. And for pointer variable is going to have different memory allocations would be given, and pointer variable stores address of another variable. It doesn't store values. Until and unless you use dereference operator, that is star, you won't get the value, right? Now we'll jump to the pass by pointer. So next example we're going to see is pass by pointer, that we skipped that earlier. So I'll create one more program that I'll write as 11 pass by pointer. So here we're going to pass by pointer CPP. All right, I'll clear this terminal. Clear. Now we got everything clear, right? So I'll write the header file here, hash include iostream using namespace std. All right, and I'll write the main function, main, and I'll define the function, I'll come out of it, and I'll write the scope of it. Alright, this is all done. Now for the swap, we're going to see that swap functions again. So we're going to swap two numbers using pointer. So how to do that? So before that, I'll create a function that is of void type. It is return type is void, and I'm going to write as swap, and inside that I'm going to pass parameter as the variable, and we're going to pass what? Pointers. Here we are going to pass parameter as pointer. So int x and int star y. So these are the pointers we are passing, and in the scope we're going to write the definition of it. So we know how to swap it. So we'll write int temp equals to star x. So it means x is value going to assign to the temp, and after that star x is going to equals to star y. So y is assigned to x, and star x is then assigned from temp variable. So this is what swapping of two numbers. Then for seeing the changes, like different memory allocation is given, we'll write cout, and inside that we're going to write x, and that is equals to, we're going to write that star x. Here we're going to see star x, and after that we're going to write star x. All right, then after this we're going to write for the y value also. For y value I'm going to write y, and then equals to, I'll give some space here also, I'll give some space to it so that it doesn't come together, and I'll give star y, and at the last I'll give endl statement, end L. All right, so this is inside the swap. Now from the main function we're going to do what? We'll call this function and we'll print the value here also. So int x comma y are the two variables I am taking. I declare these two variable. Then I'm going to take input from the user, and going to take x, and going to take another variable that is y. So these two inputs I am taking from the user. Now I have to call the function swap. So here how to call that function? We have to pass the addresses here, because these are pointers. So pointer stores what? Addresses. So we have to give address of x, not only x. So I'll give address of x and address of y. So these are the two values, address we gave, not values of x and y. And after that, here we are exchanging the swapping the value. We will use dereference here, and we are printing the dereference. We are not printing address, right? So this is what calling of function. At the last I will draw run the code also. All right, so this is calling of function. Now here what I have to write is, I'll write the cout statement, and here we're going to write same exact this thing. So I'll just copy from here and I'll just paste it, and I'll remove this one, and I'll hit Control S. So we'll see that both values, whatever the values it will come, it will give different output. Now here what I did is, something wrong it's showing. What is wrong? We have written. So here not star x will be there. Here only x variable will be there. X and y. Alright. So here I'll remove the stars. I have to remove the stars. And so here x and y will be printed, and here it's pointer. So it's going to be star x and star y. I'll save the code, Control S, and I'll run the code. After running the code, it is asking for the value of x and y. Suppose I want to replace 45 and 90. So I'm giving value x as 45 and y value as 90. So here it will print. Before printing this one, this statement will be printed after swapping. It means it should print 90 as x and y as 45 because we are swapping those two numbers. After that, that exact value is going to be printed. Now if I hit enter here, you see x equals to 45 and 90. This statement is getting printed and it is printing y equals to x equals to 45 and 90. So what we can see is it's printing 45 and 90. So something wrong we did. Okay, we find in the 9th line I'm assigning value to x. No, we should assign value to y. All right, now I have to, one more thing I have to change. I have to print this statement before this swap function. So I'll paste it here. All right, now we'll see that before swapping x and y value is this, and after swapping value will be different. So that we're going to see. So this is what passed by pointers means. What we are passing the address and it is passing the, we are passing pointer here. That is what passed by pointer means. So if I run, I'll save the code, Control S. I'll save the code, Control S. Then I'll click on run code. Then it will run the code. Let's run the code. Okay, I run the code. Now I'll have entered the value 45, 90 suppose, and if I hit enter, you see calling of function is happening. Before that 45 and 90 is printing from this line 18, line number 18. This is printing the value 45, 90, and when I call this function 19 line, it is jumped to line number 6 and here it prints this one after swapping. We gave x as 45 and y as 90. Now it is get swapped and x is 90 now and y is 45. So this is what swapping of function using pointers. This is passed by pointers. Now we're going to see numbers of example how pointers is related to array and all those stuffs. We'll end this demo here.
Thank you for watching this video. If you like this video, please do share with your friends and the colleague, and also do subscribe to ScholarHat YouTube channel and click the bell icon so that the information about such video you will get automatically.